Hello everyone. If you have heard about smart cities but you do have no concrete overview or idea about what are the applications that can be used in the smart cities or how how it works or what is the structure of one of these cities, how it's connected to each other, what is the cloud there. So through this activity 5.3.2.8 from connecting things playlist course, you will have a close view on with an example about one of the smart cities, and the file is here. As you can see here, this is a smart city. We have ISP cloud, we have also smart grid, we have smart home, we have smart parking, we have city office, and then we have smart traffic. Okay, so for smart home, you already had an example about it in one of the videos that I made before in this playlist. So please, if you still don't know it, return back to it and take a look on it. Try to understand it. Also about smart grid, and now we are going to have through the smart city a smart parking. There is a park for cars, and then we will see how can an application be deployed there. And also we have smart traffic, so when there is a street there are traffic, so how can the city automatically manage the traffic to give a priority for some cars with like for example the ambulances. Okay, so let's get started. So the task is here. As you can see, it's implemented again in Packet Racer, and the objectives are: first we are going to explore or get a look on this city, the smart one, and then we are going to analyze the usage of the cloud computing in the smart city. Alright, so in the background in this lab you will explore a smart city, so the idea of the city, the base on the premise of which takes advantage of the software to monitor and analyze the various events and make decisions on important uh, situations. Alright, okay, so the idea is that in the smart city we have different clusters, and these clusters are all connected. And as you can see here, we have the cell tower, and then we have here the one to the ISP cloud, and then we have also a smart home, and then we also have here a city office. For a city office, we can connect through these lines, the red serial lines to between the clusters. Okay, this is version 7.3 by the way, just to remind you, and here let's go through step 1. So we're understanding the devices that comprise the smart cities. So let's go to the ISP cloud and examine actually which the resources that can be offered here. So let's see here the ISP cloud, and as you can see here now we have here the main router. Here we have central office server, we have HTTP server, we have also another cloud, and here we have a coaxial splitter. There is a data there, as you remember. So let's see here what is there. We can check, for example, services. We have DHCP service, we have DHCP also version 6, and so on. Okay, so we can return back from here. And we can answer now which city networks are connected using the red serial cable. So you can see here we have a smart grid, we have also a city offices. So these two connected through the ISP cloud. Alright. Then which city networks are connected using a blue coaxial cable? So you can see here now for a blue we have a smart home, also we have the cell tower, also we have the city office. Okay. By the way, the ISP cloud provides citywide access to various individuals and organizations. Okay, so this is an internet provider. Click back button. Which city network are wirelessly connected to the cell tower? As you can see here, to the cell tower, we can see that the city offices and also smart parking, and here also we have a smart home. And we also can distinguish what is the difference between red and the blue cable. So for the blue cable, the blue coaxial cable connections is used for traffic control. So here for the traffic, I mean the internet traffic, while the red serial connection is used for the internet traffic. So here we have internet access as well, and there we have the blue is used for the for for the control, because there is a data and there is a control like in the network. So for the controlling the data, we have the blue, and for the data itself, or for the traffic or for the internet, we have the red line. Okay, so if you would like to send the control data, then you send it through the blue cable. If you have the normal data like internet browsing or something, you can use the red. Okay, so click on the blue button. Which devices in the smart home are connected to the cell tower? We already answered this. Which devices in the smart parking cluster are connected to the cell tower? Let's see here. And as you can see here, we have the wireless, which is connected to the parking street light, and here also. So these are connected to the smartphone is connected to um, the tower. We also have this parking router, we also connected to the tower, plus we have the data is also connected through the serial red line. Okay, so in general we have smartphone and we have the S parking. Okay, which device in the smart home are connected to the cell tower? We can see here we have the smartphone and we have also the tablet connected to the cell tower. Okay, now let's move to step part 2, which is about the smart parking. So here you can also take a look, start to check the devices here. For example, which is this is grid, this is smart home. We covered it before. This is the gateway here. The configuration, there is the wireless, you can see attribute there, and so on. So for GUI, what we have here, and so on. So take your time and try to learn and explore these clusters. Okay, so in part 2 we are going to check the smart city is made up of a number of systems represented by example by clusters. The smart parking cluster allows city officials and citizens to benefit from the IoT implementations. Okay, um, so here let's start to read these few lines. The devices in the smart parking cluster can be monitored and controlled remotely through any computer in the city offices here, because all smart parking clusters devices connected to the city IoT server. As you can see here, we have here city IoT server, because all the devices are connected here, so we can control or monitor them from here. So this is the server of the IoT devices, should be registered there. I mean the sensors and the IoT devices should be registered in this server, as you already know from previous videos. Okay, so let's go to the city IT laptop, as you can see here, and then let's go to the desktop, and then we open a browser, and then we type 195.0.0.2. Okay, so we need to use the username and password park, and another park here as the password, and then sign in. And as you can see here, we have the parking space. Here we have park space 1, which is, you can see, metal detection 0. What is metal detection? You will see there is a sensor for a metal, and when this sensor detects a metal, then it means that there is a car there, and then this will be occupied. Here we have also parking street light 2, and here we have also parking street light 1. And here we have P street camera, we have parking space 2, parking space 3, 4, and 5. So here we have in this park that you are going to see, like here, we have 5 parking space 1, 2, 3, 4, 5. And as you can see, all of them are free. Okay. As you can see here, the parking meter register themselves to the server and send status updates periodically. Click parking space 1 monitored and expanded. What actually you can see here in the display. So you can see here 0. Alright. Go back to the City IT laptop windows and look back to P space expanded. We already answered this. So let's go forward to step 2, and now we are going to interact with the smart parking cluster regular citizens. So now we were here as someone or officers or like employers in this city office. Now what about for a regular citizens or regular people? That, for example, one of them is using this car here. Okay, so let's take a look. Let's keep this open still, and then let's see what we have to do. While useful as monitoring tools for city administration, regular citizens shouldn't have access to the interface in the server. Okay, because this interface is only like monitored or managed by some authorized people. Okay, so the citizens cannot access this page that I already minimized. So yes, this is, I think we understand this. To allow citizens to monitor what parking spaces are available in the given street, another web page should be designed. Okay, so close the City laptop window and navigate back to the smart parking cluster from the smartphone. Let's assume that there is a person here. He is driving and he has this smartphone here. And now he wants to know if any of the places are free, so in order to park. Okay, so let's go to the smartphone here and go to the desktop, and then we need to enter the IP address 10.0.10.10.10, and as you can see here we have this new interface. We have parking, all the spots are free, so any park can be occupied by this person. Okay, what do you see after the web page loads? We see what this one here. Okay, without closing the smartphone window, drag the green car onto parking spot 5 parking spot and write almost parking slot to the smart parking. Okay, so we need to take this one, and you can see this is 5, and let's assume that one is going to park here. Okay, so now after a while we see now parking spot 5 is taken. Let's move and see the application here. 5 is now 20. It's not 0 anymore. It's not free. Okay. So here the parking spot not only reported the IoT registration server hosted in the city office cluster, but also reported to the local parking server. This allows the citizens to browse and learn about parking spots available even before they get to the street. Okay, take some time and explore the code running on the parking server MCU. Okay, let's do this. Where is the MCU here? This is the parking server. Let's go to the programming, and you can see it's written in Java, and there is the code here. Okay, you can spend time understanding, modify it, add something extra, add more tools. For example, you can here put a light, or you can put here some like sprinkles or any tools from here and connect it to the server to be set to like just play around with it. So you can do what you can use your mind and imagination as well. Okay, so MCU, this is, we know what is there. We have here the pins. Here we covered this also in one of the videos before in this playlist. Okay, so that's all about the parking application. Alright, what about part 3? In this part now we have another application which is about smart traffic, which where allows emergency vehicles like ambulance or police, such as ambulances or paramedics, to communicate with the traffic light system and request free passage to in case of the emergency. Navigate to the smart traffic cluster. Okay, we go here and we can see now we have a red in the traffic light, and then we have an emergency vehicle here. Okay, so click and drag the paramedics truck and place it close to the traffic light. Okay, we put it here, and as you can see, as we put it close to the traffic light, automatically the traffic light changed to green to allow the car to pass through. Okay, after it passed, then it goes again to be, the traffic goes again into the original state, which was red. Okay, so again move the paramedics away from the light traffic on the right and place it close to the red car again. What we will see, okay, so you can see here again it's green, and then here it's red again it's red. When it's coming again here it's green, and so on. So when I put this car somewhere, it's still, like you can see that it does not have a priority to change the traffic light. Alright, the paramedics vehicle sends a message to the MCU, which is this one here, to control the traffic lights and request passage or passing. The MCU recognizes the paramedics as a legitimate emergency vehicle and grants it passage by tuning the light green. The MCU also turns are related and so on. So I think the concept is clear. What we also need to check the code written in this MCU, and as you can see here, let's see what is going to happen. And as you can see here, emergency vehicle approaching, and now here again receiving signal, and then again to red. So here we have a function. So take a while and, for example, try to also add extra applications or appliances using IoT in this smart city. Okay. In a reflection, when sensors here, for example, we have as a reflection, when sensors, software, and servers are interconnected, it's possible to gather data and monitor events. This allows decisions to be made based on event-driven data. The key point of this example is to show you the interconnected things can monitor and ask if they are capable of executing programs connected to a sensor or actuators connected to another devices via networks. Okay. For some challenges, what parts do I need to it's here you think about if you can make a smart chair. This records the weight of the people who sit on it, and the question that may guide you through the decision are, what parts do I need to make this project. So what we need MCU, of course, or SPC. We need cables or wireless, or also we need sensors, of course, to measure the weight. And then we need, what language do you have to use, Java or Python? And do you need an internet server on a cloud subscription? Yes, we need to connect it to the server, of course. And can I build a flowchart of the software code execution? Okay, this is one example like smart chair. You can use smart anything. That's why it's Internet of Things. Okay, that's all for this video. Thank you, and I will see you in the next video. Bye bye.